So we will be starting the lecture number 14, which will be on standards, policy, health, safety, protection, reliability, sizing, and seating associated with the hydrogen technology. This will be delivered by Professor Jahangir again. Over to you.
Welcome back. So here this lecture is nothing like technical. All the information is publicly available, and I'm actually not working any of the topics in my research group. So, but still I'll try my best, to explain what I have learned, by reading some online material. So here you can see that it does involve number of things, like the policy, standard, health issue, safety, and how we can protect like the different devices, worker from the danger that it has from like or it can produce from hydrogen technology. And then what are the different sizing of the technology available in the market and their seating as well. So let's start with like what like the people's perception about that green hydrogen system. So one of the like study done in Japan, and they asked like initially like in the left hand side you can see that how much you do actually know about this like falling energy technology. And the answer option is I know it, I have heard about it, and I have never heard about it. So if you think like the hydrogen, only 20% people actually they know about this technology. Another 43% they have heard about it, but they don't have any knowledge about this technology, and 30% they even had not heard about this technology as well. So I think in terms of knowing about this technology, you can see that like solar, wind, they do have like people have better knowledge about solar, wind than hydrogen, and that actually makes sense because hydrogen is comparatively, mainly the green hydrogen is comparatively new technology, right? I don't know about like in Australia or India, like how many percentage know about hydrogen technology. I don't think it would be like even 20%, right? People might heard about it, but knowing about this technology, only people who might be like interested about doing some research or doing business or making some investment, they probably know about it. And the student might be who are studying chemical engineering, electrical, mechanical, they might also know about it. But what I'm trying to say that actually we need to do more work, to deliver the message to the community, and we also need to have like workshop discussion so that they heard about the technology, and not only hearding but also they know about this technology as well. So again, in terms of like more details about the hydrogen, what like they are finding. So they are asking like whether hydrogen is harmful to human or not. Is hydrogen lighter or heavier than air? Does hydrogen smell or not? Is hydrogen inflammable or not? Does hydrogen need other energy to be used as energy or not? But here also you see, like, I do not know, I mean it also depends the cohort, I mean they conducted the survey, but I believe this is survey more like people who already know about the hydrogen technology, unless they can't answer, right. But even it does, many people does not have, I mean real understanding about, like, the hydrogen property, about, like, safety feature that, I mean you need. So, I mean in those respect also, I mean those of us, like, working in the hydrogen, also we need to do further study to know more about the other aspect of the hydrogen, not only the hydrogen utilization, but while we are utilizing, how we can ensure, like, safe operation of the technology and also for the operator people who are using. So, we need to do further study, because in many cases what happen, we are always interested the area that we work. In most of the cases, I mean if something comes which is not relevant to us, we just ignore it, but actually it is a good idea to know pros and cons of any technology we use. So, this is one of the, like, 3-dimensional framework that people who are working on that, social science and things like that, they use, like, to provide, like, a structured way to understand how society interacts and influence the adoption of hydrogen. So, here you can see that there are, like, 3 component here. One is socio-political acceptance, another is like a community acceptance, another is like a market acceptance. And depending on here which whatever the, I mean point you are, it will tell you, I mean like here this 3 party, how the acceptance level, like, here. So, this sort of approach, I mean they use, like, to gather, I mean those information regarding safety, acceptance and so on. Now, what actually characteristics that hydrogen fundamentally different from, like, other conventional fuel like gas and gasoline and natural gas. So, these are the, like, characteristic of the hydrogen, which is quite important. So, hydrogen is colorless, probably you already know, is odorless and also lighter than air. So, this is actually very light, even lighter than air. It disperses quickly when actually it releases, and that is how the safety is also quite important for hydrogen technology, and it is really highly inflammable, not in, I mean flammable. So, if something happen, I mean it is quickly, even with a small amount of energy, I mean you might get fire, and also it has got quite wider flammability range from like 4% to 75% in air, and as I said, like a low ignition energy is required, meaning even a small spark can ignite it. And because hydrogen flames are nearly invisible, so I mean detecting a fire visibility can be very difficult as well. So, that is also another aspect. The safety things also we need to take it very seriously when we are working with hydrogen, because it is not visual. And what actually makes hydrogen, like, so much dangerous. So, that is few of them I already mentioned. So, these are the things that high flammability, low density, wide ignition rates, high diffusivity, odorless and colorless. That actually makes hydrogen more dangerous than other gas. Then these are the property, and it does mention, like, why it is dangerous. So, high flammability means that it ignites at low energy and burns with an invisible flame, that is I mentioned. Low density means it escapes quickly and increasing the risk of leaks. And wider, we already mentioned 4 to 75%. High diffusivity is spread rapidly in the air, making leaks hard to detect. And as it does not have any color, sometimes also it is very difficult to identify leak without having any sensor. So, in those cases, I mean people are working, they actually use very reliable sensor I mean with this technology as well. So, the sensor required not only for doing different measurement by measuring different signal, but also for safety reason also people use sensor here. And here again I mean as I say like the explosion, fire, cryogenic burns and material incompatibility, that are the different safety hazard that involved with this hydrogen technology. Now, the first one as I say like the fire. So, the fire the cause is the hydrogen is extremely flammable, that I mentioned. It ignites easily even with a small spark. So, unlike natural gas or gasoline, hydrogen burn with an almost invisible flame, making it really hard to detect, and this actually increases the risk of unintentional fire in industry and laboratory setting. So, that is why we need better risk assessment and safety level even in the lab as well. And this is giving some of the facts, like it ignites with as I said like very small part. So, it even only need 0.02 megajoules. So, it is even a milli, so it is like a fraction of millijoule that can cause a fire. So, you see like what sort of a small energy actually that can cause a fire. And flammability is we already mentioned 4% to 75%, making leaks highly dangerous. And the color and no smell and color, that also makes things more difficult as well. The second one like the explosion. So, it does not only cause fire, but it also cause like explosion as well, and it can occur even as I said like certain amount of hydrogen accumulate in a confined space and an ignition source is present. So, if like small hydrogen accumulate in a confined space and in case if there is a ignition source is present, it can actually produce explosion as well. And here even a tiny spark can trigger an explosion. Hydrogen air mixture between 18 to 59% concentrate can actually do that detonate. Fast flame progression, hydrogen flame travel at actually very high speed, and that actually increases damage if mainly say like a enclosed space. Material incompatibility. So, hydrogen can also make certain material weak and brittle, leading to produce cracks, leaks and equipment failure, where hydrogen atom penetrate the metal surface and can cause structural damage over time. So, if you have got like an stainless steel and aluminum, while that regular steel and iron could be vulnerable, in case of pipelines, storage tank, valves, that must be designed with that hydrogen resistance materials, and equipment exposed to hydrogen for long period also can crack and break unexpectedly as well. So, that is why this sort of hazard we need to take it seriously. So, other thing you already know that hydrogen can be stored like gas at very high pressure or even liquid like at very low temperature, and also like solid as well. But when the liquid hydrogen is stored, this like you see that it minus 253 degrees centigrade. So, making it like one of the coldest substance on the earth. And what can happen if you have that sort of like cold things, and if it comes like in contact either your skin and eye, it can actually cause several tissue damage, and also it could be like in your skin as well. So, it can damage as well. So, it is not only like fire and a very high temperature, also like we have to be careful when we are dealing with the liquid hydrogen as well. And these are the facts. I mean, it can freeze human tissue, I mean, within second. Metal surfaces exposed to liquid hydrogen become prone to cracking as well, and that is why we need proper personal protective equipment, including gloves, face shield, if you are really working and doing experiment with different forms of hydrogen. And this one just compare type of explosion that can happen. One of them is faster and another one is a little bit slower, but that actually compare whether it is speed is less than the sound or faster than the sound, but both of them actually quite dangerous. So, I will probably just skip this one. So, these are the some of the characteristics of the detonation which I mentioned, that high speed explosion with shock waves. So, the flame front can moves at like 343 meter per second, which also sometimes reach like very high speed as well, and that can actually create a shock wave, and that can cause actually severe structural damage as well. And when it is actually stored like in a confined space, like an inside tank or like a closed industry facilities. So, that type, I mean, this sort of dangerous things can happen as well. These are the some of the symptoms, like it could be the hydrogen level like low, moderate, high, and what could be like the health effect. In the low cases, I mean, it might be no immediate effect. If you have got like the moderate, where oxygen is below that level, because that hydrogen does use oxygen. So, in cases if there is a leak or something like that, the oxygen can go very minimum level, and that can produce like headache, dizziness, and sometime it might be like the loss of consciousness as well, which can bring like potential fatality as well. So, we need to check the oxygen level. I mean, if you work in a very confined space with hydrogen. So, that is why you already mentioned that there are sort of different health risk involved. It either you have got gaseous or liquid or even in a confined space. So, and all of this then can cause different level of accident and injury as well. So, if you compare the like burning speed of hydrogen with others, you can see that the hydrogen warp speed is very fast, while actually spread very rapidly if you compare with natural gas, gasoline. So, you can see this is like only 0.4, wherever this is like almost 3.5. So, it is really high if you compare it with other gases. And this safety level is not only like in one section, it could be either in the production, it could be either storage, or even it could be in the transportation as well. So, that is why I mean the safety level you need for all cases. If you work either production or storage, or even somebody in the transportation sector working with the hydrogen vehicle, in all of the cases, I mean there are safety challenges, and we need to take appropriate measure to reduce the risk. And here, I mean, if you think about hydrogen production, these are the few processes. We already explained number of processes you can use, like while you are producing hydrogen, and as usual the electrolysis, we said like this is one of the like widely probably utilized method that will be coming in the future, although not now. So, if it is electrolysis, the risk could be relevant to electrical, because we does use like electricity coming from different electrical sources, and also thermal and explosion risk, and this can happen like either fault, overheating, gas leaks, or even electrical arc from electrical arc as well. And then steam methane reforming, as we explained, this is one of the method which use like very high temperature, while this is like a very low temperature, but this one actually it will be very high temperature. And where you have got high temperature, I mean if something happen, you might have like the flammable gas, and also like the toxic carbon monoxide as well, which is quite dangerous, I mean for our health as well. And then the other method like either biomass and also the byproduct we are getting. So, from that also, I mean there are some health hazard as well. What are the protection, I mean you can take to either minimize or completely remove. So, you could have like explosion proof enclosure and very intrinsic safety design, considering what sort of safety level you have. Based on that, that I mean there are safety design as well. Redundant pressure and temperature sensor, so that you monitor exactly what the pressure and temperature currently working. Automated emergency shutdown system, so if anything happen, the system will shut down automatically. Also you need to routinely test leaking, and also you should have I mean real time gas detector as well. So, in the room, if anything leak, I mean it can automatically detect that there is a gas, and then based on that you can take like an immediate action. You should also have proper ventilation to prevent gas accumulation, and then like for designing hazardous area, this is some of the standard people use. So, while we are doing this production area, probably we should also comply with this one and also other standard we have as well. So, even in the either university or other level laboratory, also we need to make sure that we comply like the national level defined standard and also university health and safety protocol. So, this standard, as I said, that's actually mainly classify area where you have got explosive atmosphere, and that can occur to ensure the correct selection of electrical and mechanical equipment. And also for like hydrogen production, there are different level of zone, and based on that you have to take like an appropriate level of risk. And it says like zone 1, zone 0, zone 1 and zone 2. So, zone 1, an area where I mean an explosive gas atmosphere is present continuously for long period or frequently. Here atmosphere like to occur in normal operation, and zone 2, an area which is not likely to occur in normal, but if it is occurs, it will exist only for like a short period of time. So, depending on that, I mean definitely for zone 0, I mean you need to take very highest level of risk, because here as I said, an explosive gas atmosphere is present continuously for long period of life, or it might happen frequently. But in other cases risk level could be high and moderate, and based on that there are some I mean relevant example is given relevant to hydrogen. So, it could be that this one zone 0 could be inside hydrogen storage tank or electrolyzer enclosure, which is relevant to like zone 0, area near hydrogen pipeline compressor that relevant to zone 1, and if we have got well ventilated room like housing hydrogen equipment and outdoor hydrogen dispenser. So, that is zone 2, which is again like well ventilated. So, already protected, but still I mean there is a moderate risk. And then like generation, even for storage also you have got safety challenges, because storage you already know that we store in very high pressure compressed gas, very cold compress, and also recently we are also doing like solid hydrogen stored as well. And this is like different sort of number facts. We already mentioned what sort of pressure we utilize, what sort of temperature, right. So, as we have got very low, very high pressure, and sometime the devices we use also utilize high temperature, like that the high temperature mainly for the production, but for storage like high pressure and very low temperature, that's the mostly two hazardous area for storing hydrogen. And here again I mean it has got different type, like type 1, type 2, type 3, type 4. So, type 1 like the cylinder, which is like use like different like the metal cylinder for storing hydrogen, and then type 2 like load bearing metal linear types of material normally used for type 2. For type 3 non loading bearing metal, and then for type 4 also like different other materials as well, but again I am not expert on those different types of material and their characteristics, but in any cases I mean if you know like about those like vessels and other things, but it is given here and also given online as well. I mean if any of you want to work in the storage hydrogen as well. And for storage also it can cause sometime leakage. You might have like high pressure rupture, like failure of tanks or fittings that can cause like violate explanation and other health hazard. So, in those cases also I mean we need to take that safety challenge seriously. Here also like some other risk for liquid hydrogen that we mentioned, I mean very like low temperature, even like solid state storage, also like thermal runaway toxicity. These are the two risks that we need to take if it is storage like the solid, and therefore like there are some even for storage there are some mitigation measure that we can take, like pressure relief valves, and then hydrogen sensor real time monitoring, ventilation system, vent stacks, and mostly like type 4 composite pressure vessel with layered containment that give like better safety level. And also we need to do like periodic test. We should also maintain safe distance as well. And then for also transportation, there are risks because we do use like onboard like hydrogen, and if any accident happen, it also got I mean health risk as well. So, the hydrogen is transported not only used in the vehicle, but also transported pipeline, tube trailer, different tankers, chemical carriers like ammonia and so on. And if you have like a pipelines, sometime pipeline also might have like technical concern related to the pipeline transportation transmission. So, whatever like we material we use, if there is a leak, then I mean probably it could be dangerous whoever living close to that particular area. So, here I mean there are some like potential solution that can be utilized to ensure that there is no leak from the pipeline transportation. So, you can use like this sort of material which has got better safety rate for hydrogen distribution. And then if you have got the tube, that also like hydrogen compress like this sort of tube at very high pressure, and again I mean if there is something happen here, this is also like have got severe health hazard as well. And there are some accident already happen, it is not that it did not happen. So, there are already some incident happen due to those transportation issues, and here is mentioned like for pipeline and other type of things, what are the risk, whether it is leak, whether it is toxic exposure, and there are like relevant to hydrogen, what sort of risk, it is a high risk or it is a small risk, but in any cases I mean we have to take that transportation issue seriously. And this one mentioned like for the overall transportation, what sort of mitigation measure you can need. So, you can use like use of hydrogen compatible materials, inspection like all of these cases regularly, pipeline leak detection system, isolation valves, like we should also have better training that if any emergency cases happens, how we respond, and GPS monitor transportation and pressure logging, that also might help even to make it more safer. Now, that is more like what are the hazard and safety level. Now, there are some standard already available and people are also working with like different standard, and you might know that standard are defined like as a set of available rules. They define different products, system, process. They also set out some testing requirement. They also enable trade, measurement and quality checks as well. So, all of this like mentioned in the standard. Now, in Australia we do have like standard Australia, also India you do have like standard India. So, they are some sort of organization with who they work with like different independent non-government body with different national standard. Also, they have regular contact with international representation as well, and they do have trusted partner with government, industry and also the border community as well. So, this sort of standard is quite standard, and even for hydrogen you will have I mean this sort of body within that standard. They do regularly see all the things I mean that can happen. So, as I said they do have I mean regular meeting with different body. They develop different proposal and standard. They do have like technical working committee, and they also sometime regularly they also ask for public comment as well. So, when they have got any things released, they ask I mean comment from different body even to improve their standard. So, this is the I mean normal process how those standard develop, including even like the hydrogen. So, after completing all the process, they will finalize and they will publish and make it public, so that anyone can actually utilize that. Now, Australia we do have like one hydrogen standard development structure. So, here you see that they have got like 3 different body who are working with different aspect, and they are also having number of people. They do meet, and that is how probably they gonna have probably very massive final level hydrogen standard in coming years. And this again I mean mention like some of the benefit while we are adopting international standard. We do have that international standard for in other cases like different network, renewable energy and so on, and same for hydrogen also. I mean, once you adopt those standard, it gonna reflect the experience of industry, regulator worldwide. It gonna facilitate the international certification scheme. So those of like industry who are doing business, for example, if they develop a product here, the certified by Indian authority, but they sometimes also take certification from international community organization as well, so that they can sell the product not only their home country, but also for to other country as well. So as I say like that, the health hazard depend on different part of the hydrogen value chain. So that hydrogen standard Australia, they are actually developing one hydrogen standards tool, and that actually do involve all of them, like the production, transportation, blending with other gas network, truck transport, hydrogen refueling station. So they do incorporate all that hydrogen value chain. I mean, to ensure that they actually do consider everything. Now here some of the things that I mentioned here. So it's not only for Australian, but some of that it is quite common for other country as well. So for example, this one it dealing mainly with pressure swing adsorption system for hydrogen separation and purification. So this is more like hydrogen separation and purification, and I'll lead you to read that scope, what actually it does involve, but again this is mostly relevant to hydrogen. Then this is another one which is also relevant to ISO, maybe probably you already have heard about, but this, although this is Australian, but it's actually quite compliance with the ISO, and even the previous one it also complying with that ISO TS standard as well. And this is more like electrolytic hydrogen production. So this sub standard is mainly relevant to the production, and then hydrogen generator using like electrolysis for industrial, commercial, residential application. So if anything relevant to that, it's actually given like in this standard. This is more like again production, but this is more like the standardization of the test method for hydrogen production, mainly for hydrogen purity level. So that's to analyze that, they follow this like standard, and here you can see that it does involve number of things, which is we talked about when you talk about the different chemical reaction, that all of this things are involved in the hydrogen production. This is more like the hydrogen storage. So one of them more like design, construction, testing. The other one mostly like the pressure vessel storage, that is mainly relevant to that one. So and you can see the corresponding standard, title, and also scope are given. So later if you see that you are involving any of them, you can see which standard actually directly relevant to your work, and then you can go and read the details in details the standard. And then some of them like like cylinder storage, hydride storage, pressure vessel storage. So again depending on which storage, there are like corresponding sub standard as well. Then more like the hydrogen transport, like how you are transporting hydrogen, depending on that either cylinder or tube. Then based on that also there are some hydrogen standard available, but you will see most of the all standard is still like they are like ongoing. It's not like that they have already finalized everything, but still I mean you will get enough if you mainly doing the like the research level. And then this one more like the pipeline transport. So, pipeline transport also I mean there are some relevant standard, and also you can read what like their corresponding purpose of those standard as well. Next, blended hydrogen. So, if you want to blend hydrogen with the other gas network, then what sort of standard you going to follow. And also I mean you can see that for either blending into natural gas pipeline, in some of the cases also like there are some difference. So, you will find those I mean this from I mean different given standard as well. Then hydrogen refueling station, because in Australia as I say already there are number of hydrogen refueling station. So, they do have good standard I mean that how you going to design, how you going to operate, how you going to do the maintenance. So, there are some corresponding standard also given for refueling station as well. So, here are some more standard for hydrogen refueling. Then the final two topics as I say like the seating, one of them. So, the hydrogen seating like the decision I mean where you going to put your hydrogen I mean green hydrogen system. So, there are some key criteria that might help like to decide the hydrogen seating. So, this decision will actually impact definitely the cost, safety, environmental compliance, and also public acceptance. So, you need to consider all of them. So, for example, the factor that you need to consider as we are going to use from renewables. So, is it like proximity to renewable energy sources that going to reduce the transmission line losses and grid congestion. As we utilize water, what sort of access you have to for water, and that is mainly critical when you are going to utilize the electrolysis process. Safety distance, like whether you have got safe separation from people. So, if someone living some area, how far your system from those suburb and the area that people are living, and then zoning and land use. So, also like you must comply with local state regulation and planning scheme. If you are using land in a particular zone, that also you need to consider while you are thinking of setting up hydrogen infrastructure. And then also transportation logic, where your hydrogen going to be utilized, right, and also where you are generating, how you going to transport, what sort of mechanism you going to use it, that also you need to consider. If it is always better if it is close to the end user, also if you have got good access with the road, rail, ports for hydrogen distribution. And then environmental impact, always I mean you have to avoid the sensitive ecosystem. I mean where you are thinking of that seating hydrogen infrastructure. So, these are the some of the specific infrastructure consideration you need to take about. If you have got like the hydrogen hub, pipelines, refueling station and storage. So, again probably this one is very self explanatory. So, you can just read I mean while you have got time. Then sizing, this sort of like different sizing criteria, that what should be like electrolyzer capacity, what sort of storage tank you are going to consider for storage, fuel cell or gas turbine sizing. So, So, if you want to calculate like the electrolyzer size, this sort of like equation you're gonna utilize. So, this is like quite simple equation that based on like the demand and so on, actually you can find out what sort of electrolyzer capacity you might need for your particular application, what's like the volume and pressures that needed to find out your storage tank sizing, and this one your power output, if you have fuel cell, what sort of power you gonna give, either you design for a either house, for industry, for agriculture application. So, you know the kilowatt capacity, you will be easily able to find what of the sizing fuel cell you need for that particular application. So, again I hope that is not that boring, because as I said, this is nothing technical, and for me as a technical person, I do not know how I can make it more engaging and type of lecture where everybody can enjoy. But the thing is important that you know like where you can go if you want to find particular information. That is the main motivation for this lecture. So, again you do not need to read every day, based on your interest, based on your application, everything is given in the slide. Whenever you need, you go and read it. Thank you.
Professor. So, here all the lectures from Professor Jahangir is coming to end, and we will take 5 to 7 minutes question, then we will go for high tea. Any questions? I believe that at least that difference you know and leave this course, because many people confuse with fuel cell and hydrogen electrolyzer, both are not same. And from that aspect, again we go to the power electronics interface details that requires for the electrolyzer for giving a power supply. And finally today and yesterday some part we started discussing the microgrid application and also some grid integration application. And today was mostly the standards, codes, safety design. And Professor gave the previous lecture mostly a overview of ancillary services, what we say. So after the break, I'll have also my last lecture, which I'll be mostly discussing a particular grid code, which we tell which is more popular in transmission level for grid integration, and that is applicable for all IBR, whether it is solar, wind power plant, or even battery. So that is called IEEE 2800, and that I will be giving you an overview. And you will have, because for particularly hydrogen grid integration, there is no standards yet come up. Whatever Professor told is mostly at the hydrogen level, safety standard, and some of the thing at the chemical level you maintain. But when you say hydrogen at grid scale, and those integration, there is no specific rule is there, but people are working more towards developing or revising the existing 2800 grid. So I'll give you a hint of 2800, so that you know that what is required. If you are a developer, if you have a big solar power plant, you want to integrate to the grid, let's say Indian grid. Indian grid, we have the grid code is prepared by the Central Electricity Authority, as you might know, CEA guidelines we follow. And any renewable plant you want to integrate to the Indian grid, you have to make sure that you all those power plant what you develop follows the guidelines. What Professor told, whether it's frequency, whether it is voltage, whether it is kind of protection regarding islanding or anti-islanding, all these things. It not only you develop your power electronics or develop your system, but you have to follow the guidelines to be integrated with the existing Indian grid. So yeah, we'll have now break and we'll be back in